Hi, this video is about diluting solutions. You've probably diluted a lot of things so far, and so let's see. If you started with what we call orange juice concentrate, you buy it in a can in the freezer, and if you dump that out and then you add some water to it, you have diluted your concentrated solution. And so your final orange juice has been diluted from the concentrate. Well, chemistry, we're doing exactly the same thing, but only we're doing it with things we shouldn't be drinking. When we're doing that with the orange juice or in chemistry, the amount of the solute particles or the things that are dissolved in the water remain the same. So I counted these little yellow dots. They're supposed to be the solvent particles earlier, and there were 13 solute particles in this beaker. And all we did was add more water to them, and now there are still 13 solute particles over here. So the number of moles of the solute remains the same, but the volume is different. The volume is a lot larger over here. So this would have a higher concentration. It would be concentrated. Its molarity would be higher. The molarity over here, the moles of solute are the same, but that denominator, that liter part, is a lot bigger, our liters of solution, and so the molarity winds up being less, and so we call this diluted. So let's just remember that our solute particle numbers remain the same. We have an equation for figuring out how to dilute a solution, and it's M1V1 is equal to M2V2. Well, this M1, that capital M, remember from our last video, is the molarity. And it's the molarity of our starting solution. So that's what the 1 is. It's our starting solution. And sometimes that more concentrated solution is called a stock solution. And then the V1 is the volume of that stock solution. The M2 is the new molarity of our diluted solution. So I think the 2 would just indicate, now it's the final or the diluted solution. And the V2 would be, again, the volume that goes along with that diluted solution. Now, you will have 3 of the 4 of these, and you just have to solve for the 4th. And one interesting thing, molarity is moles per liter, and volume, if we keep it in liters, notice that the liters cancel. So what we are saying in this dilution equation is that the moles of solute that you start off with equals the moles of the solute at the end, just like we saw in our last picture. Now, interesting enough, that volume, it can be in liters, or it actually can be in milliliters. The most important thing with this equation is that whatever your volume on this side of the equation has to be the same as the volume on this side of the equation. So let's go ahead and do a practice problem. You've got 15 milliliters of 2.5 molar hydrochloric acid, and you're diluting it to 50 milliliters. What's the concentration of the final solution? Wow, this sounds like a dilution problem, so here's the equation that I want to use. And now let's see what was given to us and find out what we need to solve for. Well, this is M1. This goes along with it. You've got 15 milliliters of that concentration, so that must be V1. You're diluting it to, this is our final volume, what is the concentration of the final solution? So we're solving for M2. So what we're going to do is let's just plug and chug out our answer. M1 is 2.50 molar. Our volume, I'm just going to go ahead and keep it in milliliters. Why not? That just means that my volume on this side should be in milliliters, and yay, it is M2 and 50 milliliters. Double check, are the volumes in the same unit? Milliliters, milliliters, great. You want to see why it doesn't matter what unit you use, because watch what happens. M2, our molarity, is equal to 2.5 molar times 15 milliliters divided by 50 milliliters. Look what happened. The milliliters canceled. It's just important that your volumes be the same. So when we do this math, 2.5 times 15 divided by 50, we find out that our new concentration, our molarity of our diluted solution is 0.750 molar hydrochloric acid. There we go. Final answer. It should be a lower concentration because we've diluted it. Is it? 2.5 is what we started with. 0.75. Yep, we've diluted. Okay, now here's another problem. How many milliliters of an 18 molar sulfuric acid solution is needed to prepare 500 milliliters of a 2 molar solution? 18 down to 2 molar. Yep, this is a dilution problem. Whew, 18 molar, that's really concentrated. Well, that's our starting molarity. And we want to know how many milliliters of that concentrated stuff, so that's our V1, is needed to prepare. And so this is our V2, it's in milliliters, and this is our final concentration. All right, M1V1 is equal to M2V2. Plug in your numbers and chug them out. 18 molar, and what volume of that is needed to prepare 2 molar sulfuric acid, and we want to make 500 milliliters of it. Okay, when we solve for V1, V1 is 2 molar times 500 milliliters divided by 18 molar. Notice the molarities cancel. That's 18. There we go. The unit that we're left with is milliliters, and our answer is 56 milliliters of that very concentrated sulfuric acid. Okay, now, how do we prepare these dilutions? How do we do this? All right, well, first of all, you're going to have a stock solution or your more concentrated solution, and you're going to take some volume of it. So we calculated 56 milliliters in our last slide. All right, so you take the amount of your stock solution, and then you're going to put it into another volumetric flask. And so in this one, we wanted to prepare 500 milliliters. This would have been a 500 milliliter volumetric flask. These flasks are great for preparing solutions. All right, now because we're diluting an acid, so we're going to be talking a little bit more about acids. You always add acid to water, because this is a very exothermic reaction, and the water is able to absorb that heat that's given off by this reaction. So you always add acid to the water. Don't do it the other way around. It can be dangerous. I like to remember this by AAA. Always add the acid. So in this volumetric, I probably would have had about, oh goodness, about 400 milliliters of water. That should be able to absorb the heat. And then I would slowly add in my 56 milliliters of my acid. And then the last step would be to use our water, or whatever your solvent is, and in our case it's water, and fill it to the mark on that volumetric flask so that our final volume is 500 milliliters. All right, so here's how a problem can look. Describe how to prepare a 1 liter solution of 0.2 molar calcium chloride, and you're starting with a 3 molar solution. All right, well, let's see. I've got an M1, it's 3 molar. I sure don't know how much of that I need, so that's what I'm solving for. To prepare a more diluted solution, 0.2 molar calcium chloride, and I want to make a whole liter of it. Let's see, here we go, 1.0 liter. Let's go ahead and do the math first. So M1V1 is equal to M2V2, and we have a 3 molar solution. How much of that stock solution are we going to need to prepare this more diluted solution, which is 0.2 molar? And, you know, we're preparing it for the lab, so we need quite a bit of it. I'm just going to say 1,000 milliliters, same as 1 liter. All right, so when I go ahead and solve for x, my x turns out to be 67 milliliters of the 3 molar calcium chloride. All right, describe how to prepare. Okay, step 1. Okay, describe how to prepare. Step 1, I would take 67 milliliters of the 3 molar calcium chloride. I'm going to make up, 500 milliliters of it. Or no, I'm making up a liter of it. Yeah, I'm making up a lot of it. And then I will add this to a volumetric flask. And I always like to have some water in that when I start with. So I'm going to be putting it into a 1 liter volumetric flask with, oh goodness, I would say somewhere about 700 milliliters of water. Well, somebody just came home, so Gracie's saying hello. All right, and then I'm going to add it to a 1 liter flask that already has some water in it. And then I'm going to, oh my goodness, Gracie. I am going to fill to the mark. And that would be the 1 liter mark with water. And then I'm going to have to invert it several times to get a good mixing. I'm going to have to label it. And I'm done. Okay, well, bring in these calculations and we're going to make some solutions in class. Bye.